It didn't arrive like a comet. No glowing tail, no dramatic flare. It appeared as a quiet moving dot. And that was the first problem. Because nothing traveling this fast should be this calm. Astronomers labeled it 3I Atlas, the third confirmed object ever detected coming from outside our solar system. That alone should have made headlines. But almost immediately something felt wrong. Its path didn't curve the way gravity demanded. Its brightness didn't match its estimated mass. And then, it entered a phase that no equation predicted. But scientists didn't panic yet. They've seen strange visitors before. They've seen data glitches. They've seen comets pretend to be something else. At first, they thought this would be another Oumuamua situation, confusing at first, but explainable later. However, 3I Atlas didn't just confuse them. It challenged the rules. The raw data came in fast. 3I Atlas was moving too quickly to be captured by the sun. Its trajectory was hyperbolic. That means it wasn't orbiting. It was passing through. This wasn't a visitor staying for dinner. It was passing by. That confirmed one thing immediately. This object was not born here. But the numbers didn't stop there. As it approached the inner solar system, its speed increased. At first, that made sense. Gravity pulls. Objects fall inward. But then the acceleration continued, even when gravity weakened. No visible gas. No dust cloud. No comet tail. Yet it kept gaining speed. But acceleration without thrust is impossible, unless something is missing. Scientists blamed outgassing, invisible gases, exotic ices, materials that don't glow like normal comets. It sounded reasonable, but then they ran the numbers. To create that much acceleration, the object would need to eject huge amounts of material, enough to tear itself apart. But 3I Atlas stayed intact. No fragmentation. No collapse. No sudden dimming. And that's where the story shifted. Because the acceleration didn't start right away. It waited. Then it changed. A delayed phase. Space objects don't wait. Physics doesn't pause. And then resume. But this did. Before the phase, motion matched predictions. Brightness stayed stable. No anomalies. After the phase, speed increased unnaturally. Direction subtly adjusted. Light reflection changed. That means the object didn't just react, it transitioned. But here's the problem. The phase change didn't happen at peak heat. It happened earlier, which breaks the thermal explanation. Heat didn't trigger it. So what did? Imagine watching a car on a flat road. Engine off. No slope. No wind. At first it slows down. That makes sense. But then, without warning, it speeds up. No engine noise. No push. That's exactly what 3I Atlas did. But nature doesn't behave like software. It doesn't update mid-journey, unless the object wasn't passive. And that idea makes people uncomfortable, because this wasn't the first time. Oumuamua did something similar. Non-gravitational acceleration. No visible tail. No solid explanation. Scientists said, next time we'll be ready. Then Borisov arrived. A normal interstellar comet. Messy, predictable. That felt comforting, like balance restored. But 3I Atlas destroyed that comfort, because the anomalies were back. And worse, they were refined. Here's something most people don't realize. We don't see most objects. Our telescopes favor bright surfaces, predictable motion, familiar behavior, which means dark, thin, or unusual objects slip through unnoticed. 3I Atlas barely crossed the detection threshold. If it were slightly dimmer, we'd never know it existed. That means our sample size is lying. We think we've seen 3, but there could be hundreds. Passing silently. Interstellar space isn't empty. Stars move, systems drift, debris escapes. Every star system leaks material. So objects like this should be common, but common things form patterns. They follow rules. 3i Atlas doesn't. It's an outlier. And outliers force new categories, but science hates new categories. Because most anomalies disappear with better data. This one hasn't. So scientists tried a different question. What if it wasn't accelerating? What if it was slowing down before? That flips everything. If 3i Atlas entered already moving faster, then what we saw wasn't thrust. It was correction. But correction implies awareness of environment. Even comets don't correct. They react blindly. But here's the twist. Some systems self-regulate, biological ones. But this isn't biology. This is deep space. Cold, hostile, silent. At least, that's what we assume. We now know complex molecules form between stars, carbon chains, amino acids, building blocks of life. So interstellar space isn't empty, but complexity doesn't equal intention. And intention is the line science avoids crossing. Because once you cross it, you can't unsee it. Publicly, scientists stay cautious. They don't say artificial, they say unknown mechanism. They say unidentified behavior. They say more data needed. But privately, many admit something unsettling. If 3i Atlas is natural, then our understanding of matter is incomplete. And if it's artificial, then something else understands physics better than we do. Neither option is comforting. Another overlooked detail: the trajectory minimized interaction. It avoided dense regions, avoided prolonged exposure, almost like it was conserving something. Energy, integrity, time, that could still be coincidence. Space is big, paths overlap, but probability matters. And the probability here is low, very low. 1 anomaly is curiosity, 2 is concern, 5 is a problem. 3i Atlas had interstellar origin, non-gravitational acceleration, delayed phase change, structural stability, clean exit. Coincidence struggles to survive that list. But humans have been wrong before. We once said rocks couldn't fall from the sky until they did. So maybe this is another moment like that. A reminder that the universe doesn't care what we think is reasonable. So here comes the dangerous question. What if the acceleration wasn't accidental? What if it was functional? A probe doesn't need fire. It doesn't need sound. It needs efficiency. Thin structure, reflective surface, delayed maneuver. But there's a problem. No signal, no radio, no laser, nothing. But that assumes communication. What if it wasn't meant to talk? What if it was meant to observe? Passive sensors don't broadcast. They collect and leave. And notice this. 3i Atlas didn't slow down, didn't approach Earth, didn't react to us. It treated the solar system like terrain, not a destination. That suggests exploration. But exploration doesn't require intelligence. Nature explores too. Randomly, blindly. So which is scarier? Unknown physics we don't understand? Or intelligence that doesn't care we're here? Right now, scientists are changing how they search. Not for brightness, but for behavior. They're training systems to flag phase transitions, directional shifts, delayed acceleration, because the next object might not look strange. It might act strange. 3i Atlas didn't answer questions. It created them. It passed through like it had somewhere else to be. And whatever caused that unexplained phase is still out there, moving, existing, waiting. The universe doesn't explain itself. It waits for us to catch up. Subscribe to Cosmic Nexa, because the next interstellar visitor won't announce itself. And when it changes phase, you'll want to know why.